Hi and welcome back to Fun Scholar Academy. Today here we are again with a new chapter. So today's chapter is work and energy, like you can see. So let's begin without wasting further time. So do you have any idea about what is work and what is energy? Okay, you know, we consume food, we eat different types of food. From the food and health chapter, you know that we get nutrition from the food we eat. Similar chapter, you have read also that not only nutrients, we get energy. What is energy? Energy is needed for us. Now, what is this energy? Energy. From where do we get energy? We get energy from the food we eat. Is this visible or I am using the black pen? So, what is energy? Energy is that kind of thing that we get from the food we eat. Now, the question comes, why do we need energy? See, I am over here. I am moving from this side to this side. What is helping me in this movement? That is, energy is helping me to move. The energy is that substance or energy is that thing that is helping me to teach you. Okay? While you play, while you study, while you read, while you do any kind of things, you need energy. So, energy is a form that is found in the food we eat. So this energy helps us what? Helps us to do any kind of work. See, energy and work are thus interrelated to each other. Okay? Without energy, you can't do work, and to do some work, you need energy. So, this lesson is on this energy and work, how they are related to each other, and we are going to know more about energy and about work in details in this chapter. Done? So, introduction part is over. Now, let's move to the next slide. See, by the end of this chapter, the students will be able to indicate various food items that give more energy than other food items. Discuss the meaning of work by taking examples from daily life. Explain why is energy needed for work. Differentiate between work and energy with examples. Different forms of energy and importance of energy in our daily life. Okay, so let's begin. First, look at this picture. In this picture, what is the boy doing? The boy is trying to move a box, right? This is a big box. So the boy is trying to move the box with his hand. What is the girl doing? The girl is taking or pulling a carriage where she has kept her favorite doll and trying to pull it towards herself. This boy is trying to push something away from himself. What is this boy doing? He is kicking the football with his leg. Again, that means he is pushing a thing away from him. Here, what we do, if you have to light this, we will pull this down. Pull down. Okay, if we pull down this light, the light will spark, right? So everyone is doing what? They are doing some kind of work. Either it is pushing or pulling, right? For now, So what is this pushing and pulling is now? Pushing is something they are putting some effort to move a thing, or they are using their effort to pull a thing towards them. This push and pull gives to rise to a terminology in science which is known as force, So let's understand this in the next slide. Now see what is happening here. The boy is pushing, pushing, pushing this carriage, and this boy is pulling the carriage. So he is pushing, he is pulling. So both are working on this carriage. Only if he pushes and he doesn't pull, then the workload have been more. But here the work is divided between them, and they can easily move this carriage by doing this pushing and pulling together. Okay? While in this case, the boy is only pushing, and here he is only pulling. But over here you just see they are doing both pushing and pulling. So what do you think? Where the item will be moved from one place to another easily? Over here? No. Over here? Yes. Because more person are involved, and the two forces, that is pushing and pulling, both are involved over here. Understood? Okay. Now just tell me whether it will be pushing or pulling. Firstly, unlocking a lock. This is a lock. Here is a keyhole. So you just insert the key and then you just turn this. So what do? You push something inside. That's why the lock gets opened. That's why the lock get open. So which force is acting over here? Pushing or pulling? Obviously, ma'am, pushing. Now, horse and cart racing. Suppose this is a cart. Okay. And this is being pulled by horse. Okay. Just don't judge my figure. I'm just doing it to make things easy for you. So, our animal is taking the carriage away. So, obviously what he is doing? He is pulling the carriage, just like the previous picture. So, horse and cart racing is pulling. Understood? Now the wind is making the kite fly. Suppose this is the kite and the wind is pushing. That is why it is moving the kite away, and that's why the kite is flowing with the wind. So here what the wind is doing? Wind is pushing. Again. Done. Now applying brakes to stop the car. So what the brake does? You generally, if you are in the bike, you just control the brake. That means you are stopping. Stopping is something what? Stopping is you are pulling the brakes. You are pulling the brakes towards yourself. That's why the car stops. Okay. So here what is applying? Pulling. Understood? Tightening a screw, just like the key lock, you are pushing the screw inside some other material. So that is obviously pushing. Turning a page. You take a book and you turn the page. So what you are doing? You are pushing one page from another page. Right? So obviously what you are doing? Pushing. And last is cutting the grass. While you use a grass cutter, and you cut, you just move your hand and cut. So what you are doing? You are pushing the scissor to cut the grass. So here again what you will do, you will push. Clear how you pull and push things to do work? Clear now? Okay. Now next. So we have done enough pulling and pushing. And sometimes before only I have told you that the effort to push and the effort to pull, this is nothing but scientifically this terminology is known as what? This terminology is known as force. Okay, just see. Introduction to force. What is this boy doing? The boy is, this is a table. The boy is pushing the table. That is, the boy is applying effort to move the table from one place to another. Right? The boy is applying effort. Okay, see, he is sweating. He is sweating so that he can move the table from this place or to that place. Okay, so he is applying this effort. And what is that effort known as? That effort is known as pushing. And in scientific term, what is this pulling and pushing known as? This push or pull on any object is known as nothing but force. Now let's read. A push or pull acting on any object is called what? Nothing but force. Now you have understood what is force. This pushing or pulling something to so that you can displace or take a object or remove it from yourself. Push and pull, this is nothing but this is force. The effort you have applied is nothing but that is known as force. Clear? A man pushing a cart, a child pulling a toy wagon, I have just shown you, girl opening a door are the examples in which a force is being applied on an object. What kind of force? Either it be push or pull. Clear? What is push? What is pull? What is force? Clear? No confusion? I hope you have no confusion in this. Now comes work. Work is what? Work. What is work? Work is what? After you apply force. What is force? Just now I have taught you. Either it will be pull or it will be push. So that you can move any object from one place to another place is known as work. In Bengali, you call work as काज करा. In Hindi, you call काम करना, है ना? So this is what work is. Okay? Work is what? After you apply force. What is force? I have just now taught you. Pull and push. Why you apply push and pull? To move any object from one place to another. Suppose this is a box. Okay? This box is over here. Okay? A person is applying force. Which force? Obviously he is pushing the box. Okay, after pushing it he drags it and the box comes over here. Okay, so this movement of this table from here to here, this process or this phenomena is known as what? This is known as work. And to do this work, what do you need? You need, who needs? The person needs what? The person needs energy. This is how work and energy are related to one another. Understood? I hope you have understood. See, what is work? Work is done when a force moves an object. For example, pushing a box is work. For example, boy is pushing a box, that is, he is doing some work. Okay? Work is said to be done when a force moves an object from one place to another. Now, why this one place to another, ma'am? Suppose this is a big mountain. Okay, this is a big mountain. What it is? It is mountain. MT means mountain. Okay. A person is standing over here. So what he is doing? He is pushing the mountain. He is pushing the mountain. Okay. A person is standing in front of a mountain and he is pushing the mountain. Throughout the day, he kept pushing the mountain. Do you think that he can move the mountain from this place to this place? Will the mountain go? Yes or no? Can he move? He cannot move the mountain. Even for his whole life, he tries to move the mountain with his hand. He would never be able to move the mountain from this place to that place. Okay, so you might say that all his energy is being getting down because for the whole day he is doing something, he is trying to move the mountain. Yes, obviously his energy is going down, okay, because his calories are being burned while pushing the mountain. But over here, after even whole day working on this mountain, he won't be able to move the mountain. Okay, so if he is not being able to move the mountain, then scientifically we will say that after whole day pushing the mountain, what did he do? Did he do some work? No, no, no. The man did no work. What was the condition for work? The condition for work is, look at this, moves an object. Just look at this. Work is done when a force moves an object, but he did not move the mountain. No movement of the mountain. No movement of the mountain over here took place. So the man did no work. Clear? That is why you have to write this. Work is done when a force moves an object. Always this thing has to move to some area, cover some area and replace its previous position. Then only you can say that yes ma'am, work is being done. Okay, suppose I have this, okay, and I am putting this here in my hand. So you can say that ma'am did some work. Okay, but if I am holding this, like this position for the whole day, even if my hand pains and the object does not move from anywhere, it just remains still in my hand, you will say that no ma'am, you have done no work. See, that's the magic of science. That's the magic of what? That's the magic of physics. So, work can only be done when you push or move or change the position of a object. Clear? I hope this thing is now clear to you. If you have any problem, please revise this. Please redo the video, rewatch the video and keep practicing. You can even, if I try to push this board for whole day, I won't be able to push it. Okay? Now experiential learning. You can try this on your own. You take a eraser or okay. Just see. I have this cup, okay, which I am placing over here in this file. So, after some time, if I just move this curve from this place to this place, I can say, yes, ma'am, I have applied some force. What force? I have pulled the cup from this place to this place. So, yes, work is been done. Okay. Again, if I push this cup back to its place or in some other place or over here, you can say, yes ma'am, you have done the work because you have moved the cup from here to there to there and there to there. Clear? But for the whole day, if I keep this cup over here and do not touch it, even do not displace its place or do not change its position, so you will say that ma'am, you have done no work. So over here it is given that you place a eraser, you just pull it, push it. So this denotes that when you are using your fingers to push the cup or eraser or any object on your which you have in your surrounding place, so you are doing some work. Clear? Okay. Now, what is displacement? See, a path is given. Okay, suppose, imagine this is your home. Okay, this is your home and this is your school. This is your school. So, you are a person. Okay, so you started taking this route. Okay, and after moving, covering so much of path, you came to this school. Okay, so this is what? This is the total distance you have covered. Okay, suppose it is 10 100 meter. This is 100 meter. So here 100 meter is your distance you have covered. But you see, there is a shortest path from your home to your school. Okay, where you haven't went to this path. You have taken a long way to reach the school so that you can waste your time and reach your classroom late to escape punishment from homework. Okay, so don't do this. This is what you guys do. That's why I've taken the example. Most of you do, but not everyone. So those of you don't do, so don't try to do this. Okay, it's just a simple example which is relatable to you. Okay. So this is C. This is only suppose 25 meters. So, see, you have a direct way from your home to school. But what you did, you just covered so much of path to waste time and you came to school. So, this is your distance. Okay, the long, how much if you travel, this is your distance covered in this path. Okay, but this is also the distance, but along with distance, this is the shortest path from your home to school, and this shortest path is known as displacement. So displacement is nothing but shortest distance between two places. Okay, for now you just know this shortest distance between two places is displacement. This is a longer path. If you take, that will be only distance. Okay, but the shortest distance will be termed as displacement in case of science. Okay, and the movement of an object from one place to another is known as displacement, and in the bracket you will write shortest distance between two places. Okay, for class 5 level only this much you need. In higher class you will come to know about displacement in more details and why it is important. Clear? Okay, done. Now next. Okay, now look at this. Can you tell how much work is done in kicking a football? See, this is a football. Okay, the boy is kicking it. So what will happen after he kicks the ball? The ball will bounce and the ball will fall in this area. Okay, so this is that football. So now from here, if it is A, the ball has moved to B. So it has covered a distance of A to B, right? This is B. A to B. Clear? So, if the ball is being displaced, that means what? Work is done. How did the boy did the work? He applied a force in the football. What is that force is known as? That force is known as pushing or kicking. These are what? These are forces. So, can you tell how much work is done? So, here work will be, the boy has started to kick the ball when the ball was at a static position, that is at point A, and he kicked. Okay, it covered some distance and came to the position B. So, this path from A to B is the work done by the boy. So, this path from point A to B is what? Is the work done by the boy. It is following all the conditions. What did the boy do? The boy came, he applied a force, right? Which force? Pushing or kicking. So what happened? After he applied the force, the boy bounced and came from A position to B position, right? And we know that work will be done with A force is applied on an object and the object is moved from one place to another. So the object has traveled from point 1 to point B. So how much work is done? This displacement from A to B is nothing but the work done by the boy. Clear? I hope it is clear. See, it is simple. The ball is displaced, meaning the work is done. And how far it is displaced indicates how much work is done. So here work is done is from A to B. If you can measure it with a tape, you can know how much the ball has been displaced. Okay, clear? I hope it is very clear to you. Okay, now this thing I have already told you. Just see. What would happen if you push a boulder on a wall? Will the work be done in this case? What do you think? I have just given you the example of mountain. See, the boulder is so big and the boy is so small. See, the wall is so thick and it is static in a place, and the boy is a baby boy who is trying to move it. So what will happen? Even if they try for the whole day to move this, will they able to move it? Will they able to move it? What do you think? Can they move it? No, ma'am, they cannot move it. They cannot move it. So over here, can we say that work is done over here? No, ma'am. Again, no work is done here. Why? Because to do work, you have to fulfill some conditions. What are the conditions? First is force should be applied. Okay, over here they are applying force. But there is another condition, ma'am. What is that condition? The object must be displaced. So in this case, no displacement is happening in case of this big boulder and in case of this wall. No displacement. No displacement. That means no work is done. Clear? Now let's read. The wall or boulder does not move from its place when force is applied. Though you have applied force, but you have not done any work. In such cases where force does not bring about any movement, we say that no work is done. Clear? I hope this concept is very clear and very easy for you. I have done everything step by step using pictures so that you can never misconcept or never understand this. Still, if you have any problem, please redo watch the video whenever you feel necessary and practice this at home. You just try on any object, you just see which objects you can push, which objects you can pull, whether you can displace an object or whether you can or displace an object, and then you yourself doing this, you can understand that whether in this case work is being done or not done. Okay, so everything, and I cannot move a mountain or wall in this camera, but I have told you, I have shown you in this picture so that you can understand, but you yourself at home can try to push a wall and see whether you can move it or not, and whether work is being done or not, and you may say that, comment it in the comment section. Okay, in which case work is done and which case work is not done, or how many experiments you have done at home regarding work, force and energy. Clear? Okay. Okay, let's know something more. Whenever a thing moves, there are a couple of forces involved in this movement. Okay, so let us first throw a ball. Just see. What the boy is doing? He is just throwing a ball, right? He is throwing a ball. When a ball is being thrown by the boy, three forces acts on the ball. What are the three forces? Number one. Number one is the force of gravity that pulls the ball downward. Not only ball, anything. If this is a cup, I'm just leaving the cup. The what did the cup do? The cup tried to go down. Anything you throw, it will always tend to go down. This tendency is of nature. This tendency is natural, okay? And this tendency is known as gravity or gravitational pull. And because of this gravity or gravitation, we can walk on this earth. We can walk on this earth, or things remain stable in its place unless it is moved by someone. If there would have been no gravity, everything would have flown out of the earth. Okay, so that is why gravity is the first force that is acting on the ball. That's why whatever height you throw the ball, it will always tend to come down. Clear? Okay, so this is the first. Second is the force of air resistance, which slows it down. Suppose you are in space, okay, you threw a ball, okay, and you will see that the ball is moving and moving and moving and moving and moving. You can never catch back that ball, okay. You can never catch back that ball. But in earth, what happens? After you throw something or throw a ball, it goes up to a certain limit only. After that, it stops. Why? Because of this air resistance. First is gravity is pulling it towards the earth. Second is the air molecules are providing a resistance. You know that even air is a matter and it has weight and it is present and can be perceived by our senses. So it is also acting on every object, right? So it is tending to stop the motion of the ball. That is why you can throw a ball up to a certain limit only. And third is what? Third is the force with which you have thrown the ball. That is, you have pushed the ball. This pushing or kicking or throwing is the force you have applied to the ball. That is the third force. Okay. So what are the three forces? First is gravitational pull of the earth. Second is the air resistance, which stops the ball from flowing continuously. And third is with the force or the effort you are throwing the ball. So three forces acts on the ball when you throw the ball into the air. Clear? Okay. So you can say that work is been done. Over here also three types of forces are acting on this ball. Done? Now see, the force with which you throw it forward, we have read. The force of gravity which pulls it downward, we have read. The force of air resistance slows it down, we have read. See, one action, three different forces. Isn't it amazing? Yes, ma'am, it is obviously very amazing to us. Okay, so today up to this only, student. In the next lecture we will know about different types of energy and function of energy. Okay, till then keep learning, keep shining, take care and see you in the next lecture.